Hello everyone, my name is M. Ganeshmani and you're watching #MGM 2004. Welcome back to my channel. My name is M. Ganeshmani, currently pursuing my PE Electronics and Communication Engineering at Sri Venkateswara College of Engineering. So today's subject is Applied Physics for Triple E stream and the course code for this subject is BPHE 202. So the topics that we are going to be learning are what is energy gap, what is Fermi energy, what are intrinsic semiconductors, the relationship between Fermi energy and the energy gap in intrinsic semiconductors, and the derivation between this relation. So the first topic is what is energy gap? The difference between conduction band and the valence band, or the space or the gap between the conduction band or valence band, is known as energy gap, which is denoted by Eg. It varies from insulator, semiconductor and conductors. The band gap is high in insulators, whereas in conductors it is low. And in semiconductors, it is an intermediate stage where the band gap is not too much or not too less, where the electrons can travel on the basis of the temperature. The next topic is Fermi energy. The energy corresponding to the highest occupied level at absolute 0 degree temperature is called as Fermi energy. It is denoted by nu or E subscript F. As we can see in image 1, the dotted lines displays the energy level, which is also known as Fermi level. And in the second diagram, we can see the division of Fermi level or the filled energy level, as this total subscripts the Fermi energy at 0 degree Kelvin without any influence of external source. So this is how Fermi energy can be understood from these two diagrams. So the next topic is intrinsic semiconductors. Before understanding intrinsic semiconductors, let us understand what is semiconductors. Semiconductors are the material which displays the property of both conductors and insulators. Its resistivity range lies between 10 to the power minus 6 to 10 to the power 8 ohm meter. As semiconductors are classified into two categories, that is extrinsic semiconductors and intrinsic semiconductors. Extrinsic semiconductors are the semiconductors which are doped with the impurities such as N-type or P-type or trivalent or pentavalent, whereas intrinsic semiconductors are the semiconductors which are not doped with any of the impurities and it is in the pure form. As we can see in the image, silicon is not doped with any of the impurities such as trivalent or pentavalent, and the conductivity totally depends on the thermal excitation, and the conductivity or the band gap between the silicon is 1 electron volt, and for germanium it is 0.72 electron volt. Now let us understand the relation between Fermi energy and energy gap in intrinsic semiconductors by this expression. As we can see in the image, EF is equal to half of Eg. This expression shows that Fermi energy is equal to the half of the energy gap or the forbidden energy gap. This is also given in the statement that Fermi level is in the middle of the band gap for the intrinsic semiconductor, which is half of the energy gap. So let us try understanding the derivation of Fermi energy and energy gap of intrinsic semiconductors. As we know, in intrinsic semiconductors, the number of holes per unit volume in valence band is equal to the number of electrons per unit volume in conduction band. So by this statement, we can say that Ne is equals to Nh, where Ne stands for 4 root 2 by h cube into pi Me star kt whole power 3 by 2 e raised to the power ef minus eg by kt, whereas nh stands for 4 root 2 by h cube pi mh star kt whole power 3 by 2 into e power minus ef by kt, where me stands for the effective mass of electron, star stands for the effective mass of hole, k stands for the Boltzmann constant, T stands for the temperature in absolute scale, ef stands for Fermi energy, eg is energy gap, and h is the Planck's constant. So by equating these both equations, we can conclude that Me star whole power 3 by 2 e raised to the power EF minus Eg by kT is equals to me star whole power 3 by 2 into e power minus EF by kT. Or by rearranging the equation, we can say that e power minus 2f minus Eg by kT is equals to mh star by me star whole power 3 by 2. By taking logarithm on both the sides, we can say that 2EF minus Eg by kT is equals to 3 by 2 ln mh star by me. And rearranging it again, EF is equals to 3 by 4 kT ln mh star by me star plus E2 by Eg by 2. Under partial consideration, the effective mass of electron is equals to the effective mass of the hole. So the right side of the equation becomes 0 as mh star and me star gets cancelled and ln1 is equals to 0. So 34 kT ln mh star by me is equal to 0. So from this equation, we can conclude that EF is equals to half of Eg, which means the Fermi level is in the middle of the energy gap of the intrinsic semiconductor, or the Fermi energy is the half of the energy gap. Thanks for watching this video. Please do like, share and subscribe to my channel. Hit the bell icon and share all your comments in the comment section. Stay tuned for more upcoming videos. Goodbye.